Welcome to our webinar today. So what we wanted to talk about was we'll be talking about occupancy-driven building management in our webinar. So for smarter energy use, healthier buildings. So today we have Sontay and MClimate and Ian Ross. We're going to be exploring how occupancy-driven sensing is transforming energy efficiency in modern UK buildings. So helping reduce energy waste while maintaining optimal indoor air quality and comfort. So we'll do a quick introduction in the next slide. So welcomes and who we all are. So I'm Stacey Lucas, so Commercial Marketing Director at Sontay Limited. So Sontay manufacture and sell devices for intelligent buildings, so sensing, switching, all of the things you need to do to empower your building to be better. We have been working over the past few years with LoRaWAN devices as well, which is where we're going to focus with MClimate today. And we also have Ian Ross on the call, so I'll pass you on to Ian and he can introduce himself. Are you on mute, Ian?
Technology. Okay, I should be good at technology, but I'm not. Okay, so apologies there. Good afternoon, everybody. My name's Ian Ross, Managing Director of M3 Automation Limited. I'm a CIBSE low carbon consultant, a self-professed energy management expert. I'm also a BEMS industry trainer as well, so I'm developing the future of the BEMS industry, hopefully. My background is in automation, plant and systems control, and BMS deployment. Thank you, Stacey.
Okay, and then we have Violeta from MClimate.
Hi everyone, nice to be here with you today. I'm Violeta, I'm the Chief Sustainability Officer and co-founder of MClimate. And as Stacey mentioned, we're also covering LoRaWAN, so basically manufacturing devices, one of the pioneers since 2018 in the device spectrum. And we have quite a big range to foster energy efficiency and mostly sustainability goals for our customers.
Okay, thanks guys. So thanks Ian and Violeta. So throughout this webinar, we will be talking about the UK regulatory context. We've got some information on occupancy-driven energy efficiency and the BMS integration via LoRaWAN, and then we'll have a discussion on it at the end. So yeah, without any further ado, we'll get moving. So the regulations that are driving demand for smart buildings at the moment. So today we'll look at those regulations that are shaping how buildings are designed and operated and improved in the UK. So rather than analysing policy in detail, I'm sure many of you have looked into that, we'll focus on what really matters in practice. So which regulations are driving demand for controls, sensors and data in our buildings? So the goal is to give you a clear view of why sensing and BMS are becoming central to building performance and compliance. So we'll walk through the UK building regs, the shaping energy and IAQ, why controls and sensing are becoming essential, and the 6 frameworks driving the change there. So it helps to think of the regulatory landscape in 3 layers. So first are design regulations, which dictate how our buildings should be engineered. So these include Part L and Part F. So second are our performance ratings, such as EPCs, which measure the efficiency of our buildings. And third are enforcement mechanisms, including MEES, ESOS and TM44, which drive building owners to improve their performance. So when these layers combine, they create a strong incentive to monitor and optimize building systems. So we'll dig a bit more into that. So Part L, it focuses on reducing energy consumption. So it expects buildings to include efficient control strategies such as zoning, scheduling and commissioning. Then on top of that, you have Part F, which focuses on ventilation and indoor air quality. So modern ventilation systems increasingly rely on demand-controlled ventilation, which adjusts the airflow based on occupancy or the air quality. So both regulations depend heavily on accurate sensing and intelligent control systems. So then we move a little bit forward into the EPC and the MEES. So EPCs provide a simple rating of building energy performance. But the real driver of action is MEES, so minimum energy efficiency standard. So I have been working quite a lot in looking at MEES with the BCIA, so we're quite familiar with it and how it applies. So MEES means buildings cannot legally be leased if they fall below certain energy thresholds. So for building owners, this creates a direct commercial risk. Improving building efficiency therefore becomes a priority, and controls optimization is often one of the fastest and most cost-effective ways to achieve this. So landlords will be looking at this very, very stringently. Moving on to that, we have ESOS and TM44. So ESOS requires large organisations to carry out energy assessments. So it doesn't apply to all, but it does apply to the large organisations. So these assessments often identify opportunities such as better monitoring, controls optimisation, and improved system management. So you'll see some uptake in moving forward on those. TM44 inspections focus on air conditioning systems. So they frequently reveal issues such as systems running outside schedules, poor control strategies, and inaccurate sensors. So both frameworks, they often lead to organisations toward better monitoring and smarter control of their building systems. So when we look across all these regulations, one theme becomes really clear. So buildings must not only be designed efficiently, they must operate efficiently. So that requires accurate sensing, reliable control systems, and meaningful data. So sensors provide visibility into how our buildings behave. BMS platforms provide the control logic to optimize those systems. And analytics helps turn that data into insights. To summarise, so regulations are increasingly focused on how buildings actually perform, not just how they were designed. EPC and MEES are pushing building owners to improve efficiency. Part L and Part F ensure systems are designed for efficient operation. And across all of these frameworks, the ability to measure, control, and optimise building systems has become essential. So this is why sensing technology and building management systems are playing an increasingly central role in our modern buildings. So for many buildings, the missing link is not plant capacity, it is the intelligence. So occupancy-driven control allows us to heat, ventilate spaces when people are present, not reduce the demand when they are not. So what we would talk about further in here is when you're using Sontay's LoRaWAN environmental sensors, so with the MClimate ones as well, so the wireless actuation and the sensors together, they really do deliver zone level response. So what we will do moving forward in the webinar is I will then hand over furthermore to Violeta from a couple of slides on, so she can talk a bit more about how that actually happens. But we'll give some brief examples of where this can make a difference. So estates and finance teams, so energy, carbon, risk management, and current estate challenges. So you've got hybrid occupancy patterns, rising energy costs, carbon reporting pressures, and IAQ scrutiny post-pandemic. All of these play a big part when you're looking at managing estates and managing the finances of estates. And that's where sensing really comes into its own. You then have sector-specific values, so healthcare. So in the UK, for instance, we all know the pressures of the NHS and how they can cut costs and improve the environments of their patients all makes a big difference. So reducing overheating and unused rooms, maintaining CO2 for good air quality, retrofit without having to, actually close some of those healthcare facilities. You can move in with wireless and easily make a big difference without having to shut anything down, and supporting their sustainability targets. Universities, the same kind of things. So lecture theatres set back during non-teaching hours. But of course, it's really important when you are teaching that those lecture theatres are, accurately and optimally ventilated, so that it's the optimal teaching condition or learning condition for those students. So indoor air quality is really important for their cognitive performance. And then again, you push back to the earlier topic about estate performance. So again, often these universities are massive estates, so they need to perform. And they will also need to do their ESG reporting. So they have some real targets to drive them. So moving forward, I will hand over to Violeta now, and she can talk on from how MClimate are talking about their key clients, the results, and some examples of how they have seen this working.
Thanks, Stacey. Thanks for the introduction. And really, I think the regulatory pressure is everywhere different, but in the same time, everyone has to do something about it. And the retrofit solutions that we offer together, sensors and gateways, are the way to go. Here is just a quick overview of the type of customers that come to us. It's anything from international banking institutions and corporates to energy service providers, metering providers, anything that's looking for data beyond the meter. But also we work quite a lot with integrators together with Stacey, where we actually provide the data points required to optimize the BMS system. In many of the situations, energy savings are driving the decision-making process, not only regulation. So what we try to achieve for all of our customers is saving between 20 and 35% of any existing system. We reduce their operating costs as well, because previously a lot of the work was done manually. And with the takeover of LoRaWAN and control, we can actually assure that you have room-by-room control without having to then go and adjust, let's say, radiators on an individual basis. I think most of the time customers also care about data collection. As Stacey mentioned that a lot of the finance teams, again, getting data for sustainability reporting or just your return on investment is quite key. And this is, again, something that we do with the sensor data. I think LoRaWAN, just briefly mentioning the technology as well, we mentioned it a few times, but for those who are not aware of it, allows us to operate with 10 years of battery lifetime due to the communication. And then it also reduces our infrastructure cost, because you work with a lot less gateways compared to other technologies on the market. So really, it's a scalable B2B technology to optimize a building with sensors, because there's a lot of sensors out there with different working technologies. Again, that kind of specific LoRaWAN functionality and the fact that you don't have to deploy multiple gateways is allowing you for the quick return on investment that we just briefly touched upon. So yeah, most of our customers see return on investment within 1 or 2 heating seasons, depending on where in Europe they are. I think currently in the UK it's around 2 years. So basically 2 heating seasons for a lot of our energy efficiency solutions. Just to walk through the hardware where we are mostly specialized in. We do hardware for sustainability, like energy, air, and water. In this particular slide, I'm focusing on the energy solutions. And again, with all our sensors and actuators, we try to get control over 80% of the energy in any building. Some are radiator thermostats. So this is probably our most common use case for retrofitting buildings. Most of them are controlled holistically by the BMS system, but it doesn't allow you for precise room-by-room control. Here with the thermostatic valve, you can have immediate scheduling for every single room or every single radiator. You gain access to data points around humidity and temperature. So you can do also estimates around mold detection. There is an algorithm that we can use for that. And then you can also have open window detection. So if there's a sudden temperature drop, we can detect if a window has been opened and then a room is being heated while it is being ventilated in the same time. So we really try to identify inefficiencies with a simple device. And that retrofit is quite easy to do with 90% compatibility of that radiator valve with the existing radiators that you have in place. Fan coils are also quite interesting. They're mostly typical for class A buildings, offices, a lot of hotels. But again, most of them are quite obsolete and old, and building management systems date back from 10, 20 years ago. So really taking over the fan coil allows us to efficiently control room by room and get the relevant data all in one system. The wireless thermostat is something that we can control multiple radiators with. So this is for shared offices, larger rooms, anything that is above 50 square meters. And then also we can control underfloor heating, which is also quite typical for the UK. There wasn't a solution that onboards all the underfloor heating in various rooms. So in this way, with a wireless thermostat and a combination of some of our relays, which I'm going to show you on the next page, it's we take over control of everything in the building. The relays themselves we have two different types. One is a dry switch and the other one is a power meter switch. They allow you to control anything from electric heaters, fans, individual presentation screens in meeting rooms, garage doors. We have a lot of use cases for every single one of those. It's kind of everything you can fit behind a socket. It's a very small device. We can control lights, fridges, and essentially it's allowing another level of energy efficiency on top of everything else. Again, probably it's not the main way you heat a building. It will be probably the fan coil radiator as the most used effect. But for electric heaters and student housing, it's one of the best-selling solutions that we have in the UK. On the left-hand side, we have the CO2 and movement detection and the HNT and movement detection. And this is the two devices that we introduce basically for the occupancy effect. So this detects a movement detection. So essentially, if there isn't a movement detected in specific rooms, you don't need to heat those rooms. And again, after COVID, there was a lot of working from home introduced in the working space. So essentially, there is a set of temperature that you can like heat the room to, basically, let's say 18 degrees in the morning. And if there is no movement in the first few hours, working hours, then we don't really need to heat that room further. So really, those two devices, together with the air quality or just humidity and temperature, together with the movement detection, allow us to optimize the workings of the buildings and retrofit the building so we make it smarter and make smarter choices around it. I think the actual is just like a quick overview of how a typical use case looks like. Again, on one side, we have all the sensors and actuators that communicate with the LoRaWAN network provider. And there is usually a gateway that we introduce in place. There's two types of the gateways. One is a specific LoRaWAN gateway that sends the data into any IoT platform, dashboard, anything that you want to work with offline and not connected to the BMS. So you have one way to control the devices this way. And then the more complicated and more integrated way to do it is have a LoRaWAN to BMS gateway, which Sontay, for example, has that sense that allows you to integrate the data points from all the LoRaWAN devices and sensors and actuators that you onboard in the project easily into the existing BMS system. In this way, you don't need an IoT platform. You wouldn't need an extra layer of software to get the data points, but you will be getting the data points in the usual way into your BMS solution. And I think this is a probably more comprehensive way to do it, since most of the buildings are already equipped with a BMS solution. We rarely have customers who really need a standalone IoT platform, but there is also a way for them to get on board into that retrofit journey as well. What you get from a simple solution with, let's say, radiators and an occupancy sensor on the wall is track energy consumption and CO2 savings. Then you have the occupancy and movement data that gives you the data insights for calculation. You get all the data in one place on a room-by-room basis. And then you have you can actually deal with the building itself in a more precise way on the comfort settings of the occupants. So essentially, in most of the cases, instead of savings or regulatory pressure, it's just improving tenant comfort. And I think Stacey mentioned hospitals. It's one of the regulated places that we do a lot of installations, and basically that the comfort is more of a driver in this case. With the LoRaWAN technology, as I mentioned, we do reduce the maintenance of all these installations. You can track the device batteries remotely. And then most of the time, depending on how often you want to receive the data, this is also something specific for LoRaWAN, you can extend the battery lifetime between 7 to 12 years. Again, most of the cases, we don't need this data every 5 minutes, but we set it up to 15 or half an hour intervals where you receive the data and then you control the building this way. And that prolongs the lifetime of the installation. So you don't have to worry about battery replacement or taking care of it in the meantime. I think here I'm just giving one simple example of what can we do to make an occupancy-based energy efficiency. Again, in most of the cases, the BMS gives you one kind of an overview. And here with the TRVs in particular on the radiators, you can use different set points and different schedules for every single day of the week. And depending on the time and occupancy, have different ways to play it out. So for example, you can have an unoccupied or empty building setting for 12 degrees. You can have a frost setup of a 5 degrees. And then you can have a setback point, which can be either at night if it's a residential or a retirement home. And it can be also a setback point for after hours, for example, for working offices, schools and universities. Again, in most cases, it's 16 to 18 degrees at night. And that already alone is a big saving in itself, just reducing the temperature at night with a few degrees. I think 1 degree is usually transferring into 5 to 7 degrees, or 7% savings on the energy side. The occupied set point, again, that differs from the use case. In most of the hospitals and universities, we get 23. In office spaces, we get 21 as a setup. And again, it is something that you can lock on one side with the devices, or you can allow full flexibility for the comfort of the tenants. Again, a lot of the scenarios work around do not heat up a room if there is no movement detected there. So again, from the night mode of 16 degrees, you start heating up at, let's say, 5 or 6 a.m. to 18 degrees. If there is no movement or a room is not occupied based on a schedule, then, or based on the movement detected by the sensors, you don't really need to heat it to 21 or 23 degrees. And again, all these scenarios, depending on the use case, we're happy to advise on those as well, based on customers we have around Europe. But really, that allows you to easily set up rules that allow you to save energy over the long run without having to intervene with your energy consumption every day. Here I'm just giving one illustrative use case. And again, I think there was some more from Stacey that specifically deal with BMS integration. This one is a historical building in London with 3 wings, 6 floors and 350 rooms. If we were to use any other technology, we would have had to place gateways every 20 to 50 meters just to ensure that there is communication. With the LoRaWAN technology, we placed 4 gateways for this building, which really reduced the cost of the whole installation. We have over 900, almost 1,000 TRV radiator devices. And half of those rooms have also HNT and peer sensor, which is detecting movement in the morning to optimize the scenarios. We have some window switches as well, which are quite interesting, just to optimize the workings of the system. Do we actually we stop heating the rooms when we have a window open detection in place? The target for the project was to optimize the commercial space and the office space being used. Again, some of it is used for events, others is like recurring exhibitions. Different office spaces are occupied at different times. Previously, the building management system was not capable of reducing this on a room-by-room basis, or even allowing to put schedules for every single room. At the end of the installation, which actually took only 3 days for the whole building, we managed to take over control of the building and decrease the energy consumption with 32 degrees. We decreased also the average temperature of the building. Due to inefficiencies and its isolation or exposure to sun, there were rooms that were heated to 25 degrees, whereas others were staying at 18 degrees. With the room by room thermostat that we introduced, we could get precise data for every single room. So that precise temperature regulation that we could adjust on the room occupancy-based system, it prevented us from unnecessary heating of a lot of empty spaces, in particular office spaces and gallery spaces on that particular in that particular building. So we use the child lock function that I didn't mention before. The child lock is just a manual lock intervention that restricts people from changing the settings. This is something that we introduce in all the commercial spaces, but we allow some feedback from people in their office spaces so that essentially they're not locked from changing the setup of 21 degrees to something higher. But really, with a small, with an easy installation, small investment, and something that repaid itself on the second year in this particular case, we allowed the zone-based scheduling for all the radiators, and we were able to completely shut down the building if needed remotely without manual intervention of the staff. I think this was most of my slides, and I think on specific BMS cases, we have Ian and Stacey maybe give the floor to questions or just give more examples from the BMS space.
Okay, yeah, thanks, Violeta. So that was really helpful. So I know definitely at Sontay we've released a couple of case studies recently where we've seen these kind of devices deployed in healthcare facilities, in health centres, in care homes, in community centres. And by simply installing things like TRVs, the window and door sensors, the occupancy sensors, we have some real life examples where they really are making some brilliant energy savings and therefore cost savings as well. So we will send, when we resend this video out and some details to everyone that's been on the call today, we can send some further details on those case studies and references because there's some really great figures in there. And so at this point, I guess we can have kind of Ian chime in because he is out in the field deploying this stuff all of the time. And he's one of his keen things is energy. So Ian knows a lot about how much of a difference this can make in the real life and as well to the regulatory stuff that we've been talking about as well.
Thank you, Stacey. Thank you, Violeta. Yes, it's an interesting time to be in the world of energy management. We're in the middle of one of the biggest focuses on energy costs that we could imagine with the terrible things that are going on at the moment. I don't need to dwell on that. But we are where we are, unfortunately. And we've got to understand that there are a lot of customers out there who have multiple financial stresses. And one of the biggest financial stresses that our customers are seeing at the moment is their operational expenditure. And of course, as energy use increases in cost, there's a bigger pressure placed on that operational expenditure. And so we need to provide solutions for our customers that not only address this increase in cost, but also present them in a way that's very economical for them to deploy. One of the biggest costs that we find in deploying enhancements to systems is the installation cost. It can be in excess of 50% of the overall project cost. So if we can remove that installation element and reduce the amount of time it takes to deploy, it makes it a really attractive proposition for customers that would not normally have the budget or the appetite to look at intrusive controls into their systems. When I use the word intrusive, I don't mean that negatively, but we are actually taking control of elements that were not formally controlled. Now, Violeta mentioned thermostatic radiator valves, and virtually every building in the UK has a variable temperature heating circuit where we do the primary control in a boiler house and we schedule the heating water temperature based purely on outside air temperature, which has worked for decades, okay? But it doesn't always work in a way that gives us sufficient heat or over the top heat. So we could be providing far too much temperature, or we could be not providing enough. But when we can deploy these TRVs that are not only controlling individual spaces, so we're getting down to the level of individual room control, we can now feed back into our system to say whether or not our overall compensation based on outside air needs is actually suitable. And we can add further comfort or further energy efficiency very quickly and very simply. So what I'm seeing now with these types of wireless technologies is a real game changer, not for the BMS industry, but for customers. Customers can be more in control of their buildings with a minimal financial impact. So that's where I really see things going from a deployment. Now, one sector that Stacey didn't mention, and there is no exclusive sector. Education is a huge sector that needs control. You just think from local village schools all the way up to university campuses. They are lots of small individual spaces, whether you've got 3 classrooms in a village school or 120 lecture rooms in a major university. Each one of those will need control. And traditionally, the value engineering exercises that we've seen from construction has meant that there's been more pressure to lower overall costs, i.e. move things out of the scheme. And individual room control has suffered tremendously over the decades because of those financial pressures. Now we have a solution that we can take to customers that is incredibly effective and incredibly economic as well. So I think it's really, really important from a deployment side of the coin. We realise how simple it is for us, the technology experts, to deploy, and how beneficial it is for the customers to engage with us.
Yeah, I completely agree. So yeah, it really is beneficial for it. Over the past couple of years, I guess I can't kind of reiterate how much difference it can make in a project. So the things that you thought weren't possible, if you had a hospital, for instance, and it's really being overheated, and you've got, if you're talking about a main hospital, thousands of radiators around a building, at least hundreds. And to be able to control that a bit better and reduce those energy costs. And not only that, make people feel more comfortable in there, because I know whenever I've been in a hospital, I really feel stuffy and uncomfortable. They generally are really hot. And to be able to ventilate, control and manage the heating and those sort of environments better, and save a shed load of cost as well in actually heating them. Why would you not make that small investment? You haven't got the downtime. You don't really need to close off anything. You're putting in wireless devices around a building. It really is such a brilliant thing to be able to do. And we've made it so much easier now with LoRaWAN devices.
Yeah, and I think...
Sorry, Alexa. I was going to say, from a real world example, recently with a partner that I work with, we deployed a LoRaWAN solution into a commercial building that was 25 years old. So we weren't going to start running new installations and everything. We deployed the LoRaWAN gateway and the sensors within the entire building in half a day. We were gathering data within half a day that we could deploy directly into the BMS. Now, traditionally, you would be talking days, if not weeks, of deployment and a lot of disruption to the customer. The customer wasn't even aware of that we were there. It was somebody turning up with installation equipment and effectively screwing a sensor to a wall, and somebody else at a panel deploying the gateway. It was over in a matter of hours. It is tremendously efficient.
Yeah, something I wanted to add on to that is exactly that point, that you don't have to shut down a building to do more cabling work, but the retrofit happens instantly. And really, with the case that I also presented, it was less than 3 days to install the infrastructure and go through 500 rooms, 2 radiators each, to install an occupancy sensor and the radiator valve to be changed. I mean, it takes 2 minutes or 3 minutes per radiator to actually onboard the devices into the system, see them showing up, data being displayed, and really like not having to shut down buildings, but not disturbing the usual operations is really a big point as well. So really, it doesn't take a lot of time and investment in actually shutting down your operations to do a smart retrofit with sensors.
Yeah, and I think for installers, so I spend a lot of time talking to systems integrators, and what tends to happen is the people that are using these devices, or would typically be using wired devices, their part that comes, so a building is built, it's been specified, designed, built, everything's happened with it, And when it comes to putting in the BMS, it generally is at the end. And, by then the builders and decorators and everyone else have overrun, they've overspent. So budgets and time are tight. So to be able to then go in and cut costs, value engineer, to be able to use wireless devices rather than cabling, spending more time on site than is needed. You can easily go into site, deploy a wireless sensing system really quickly, relatively cost efficiently as well. And it's future proof as well. It can then be moved very easily. You can do lots more with it as the building evolves as well. So there really is so many benefits to moving forward and using wireless devices. So at this point, I guess if we hand it out to the floor, does anyone watching have any questions on wireless devices, wireless sensing, deployment, regulations, anything out there? Please put them in the chat box and we'll be happy to discuss for you. Okay, so we don't appear to have any questions. So obviously we've covered everything and given everyone a good overview. I would say that we would welcome any questions or feedback after. If anyone wants to get in contact or in touch with any of us, we will follow up as well with you all and push out some more information and our contact details. But yeah, definitely get in touch. We'll be more than happy to answer questions, get involved. If you want to see a demonstration of any of these products, then we can come out to you. Our sales team and sales managers have full demo kits. They can come out and show the devices. They can show the gateways. They can show anything that you would need to see to be able to prove. We can support with site surveys and anything like that. So by all means, get in touch and we can move forward.
Oh, and we've just had one question come in.
Okay.
Imogen, can you mix and match different brands or devices?
So yeah, I mean, obviously that might be a good one for Ian about you're in the field. So would you mix and match LoRaWAN devices out there?
Yes, you can actually, but there's always a qualified yes, you can. Remember at the end of the day that it's got to have the same protocol. So if we are using a LoRaWAN gateway, without wishing to be patronising, the devices need to speak LoRaWAN. We must get away from this thinking that all wireless technologies are compatible with each other. Whenever we're talking about wireless technologies, the important thing is the protocol, the language that they talk. So if they are LoRaWAN devices, the chances are very, very good that all your LoRaWAN devices will be able to talk to the gateway. But that is a very qualified yes, you can, if you don't mind me saying that.
Yeah, and we've seen
the protocol.
Yeah, we've seen examples of that. So of many people using one gateway, using various, because it's not only BMS devices always, LoRaWAN has such a broad spectrum that it can be working on. So I know people use it for car park sensors and things like that to see whether all their parking spaces are full and things like that. So it really is interoperable, and mixing devices depending on what your needs are it is definitely possible.
Yeah, I'd agree with you there, Stacey. LoRaWAN is a technology that's been embraced by a lot of different industries. It's used quite extensively for vehicle tracking as well. So there are use cases where refrigerated vehicles are monitored by LoRaWAN devices and are tracked across nations for their performance. So using public LoRaWAN, we don't have a lot of public LoRaWAN available in the UK, unfortunately. So it's on the private side of things. You have to deploy your own gateways. But hopefully the British government will see the benefits of rolling out a technology like this. And maybe in the UK, we will see a public LoRaWAN network appear. So then it will, even in the domestic market, it make it much simpler to deploy LoRaWAN devices.
Yeah, there's a lot of councils actually we see in the UK that do their own LoRaWAN networks. It's at least 5 or 6 of them that we see have deployed it. And this is the first step. I mean, obviously they start with the LoRaWAN network rollout, and then they're going to work on the use cases. I think mold detection is one of those where you need humidity and temperature sensors, and it's a regulatory pressure to do that. But once the network is there, sky's the limit. And really, because you can mix and match brands with the LoRaWAN communication technology, then you can really work on use cases and build up on. Let's start maybe with whatever's important for you. Is it energy or air? But then build on that use case, because there is no limitation. I think there is a gateway. Okay, how far can a gateway receive a signal? Again, I think it's the general line is 5 to 10 kilometers. But again, Ian, maybe from deployments you have different view depending on how tall buildings are around and other things.
Exactly. Yeah, that's the first question that always comes about with any wireless technology. Theoretically, it's tens of kilometres, but remember that anything that gets in the way of the signal will add to the attenuation. LoRaWAN is particularly well designed to overcome attenuation problems, but anything that gets in the way will lessen your coverage. But it is a fantastically robust solution, and we are talking good distances. If there's nothing to get in the way, then we are talking tens of kilometres. LoRaWAN is used in the farming industry, in cattle. There are devices that cattle or animals will swallow, and then the farmers and the farm managers can actually monitor their animals' health through their stomach. And of course, as you can imagine, those animals wander all over the place. So yeah, it's a really clever solution. If installation is a problem, if long distances are a problem, LoRaWAN is definitely something that you want to consider. It's a very, very clever solution.
Yeah, I don't think we've had any examples of customers having a building that it can't work in and can't have great signal strength. We've managed to get everything working that past wireless systems would not have been able to. And I think sometimes there's a little bit this kind of legacy reputation, because before LoRaWAN, there would be difficulties with some wireless systems in some buildings because they would have really thick walls or metal racking or anything that would be impacting on that wireless signal. But we are not seeing those with LoRaWAN. We are seeing that most people that have taken LoRaWAN devices into their building have got excellent signal strength and really managed to deploy a great system.
Yeah, I'd agree with you there, Stacey. The first LoRaWAN solution that I was involved in the deployment was probably in the region of about 5 years ago now. And that was on a university. And we put the first gateway into a plant room in a university building. The plant room was in the centre of the building. So it was deployed into a metal control panel. So no external antenna. We were actually using the antenna that were fitted to the devices. So it was encased effectively inside a Faraday cage, inside a plant room surrounded by metal pipework and everything being bonded to earth. If you can imagine a way of reducing wireless signals, we've managed to do it. I walked out of the plant room and the estates office was it was at least half a kilometre away. I got to the estates office and I was able to demonstrate to the BMS manager using a field test device that we were still sending and receiving signals to the gateway, even though it was locked away in a plant room in the middle of a building. He was immediately sold on it, as you can well imagine. And all of a sudden, the possibilities opened up for him. Now, that's no guarantee that in every plant room, we're inside every control panel, that we would be able to do that. But I would say that was as close to worst case scenario as I've ever seen for a wireless solution. And LoRaWAN came out with 5 stars. It was absolutely brilliant.
Yeah, and that's generally the feedback I have on any project that our products have gone into, or we've gone and done a site survey, anything like that. People are always amazed by the performance. So yeah, it's a brilliant solution.
Another question from Jonathan.
Okay.
How many devices can be connected to the gateway?
Okay, so we've got the question from Jonathan. So how many devices can be connected per gateway? So at Sontay, we use the WhatsSense gateway in most of our projects, and you have different versions. So it can be unlimited. So we can start with, so what you would need to see is it's per point. So you could have a LoRaWAN device that's detecting 3 different parameters, so therefore it's using more than just 1 point. You can have anything from 100 points, you can have 250 points, 500 points, you can have 5,000 points. So it's just depending on what you will pay for your gateway on your licensing side of things. So sometimes people will utilize gateways in a different way. So if you've got a building with 8 floors, they might put a gateway per floor, just to kind of zone their building. But you could also have one gateway that's just zoning that entire building, and you are managing the zoning through the gateway. So it's kind of a preference on how you do that. But yeah, I guess Ian, Violeta may have some thoughts on that as well.
I was just going to say it's down to licensing. It's scalable. The beauty is you can start small and add to it. You know, I think that's probably one of the big ticks in the box, using a wireless solution over a hardware solution. If we go down the traditional model, most BMSs now with physical points hardwired is virtually unlimited, but each point has a physical cost. Size, space, installation time, skill set. With a wireless solution, with a licensed base option, you just buy another device, and if you've run out of points, you buy an extension license. It is as simple as that. So, you know, if you are looking to enhance your system, this is a very, very simple way of enhancing your system with minimal impact, and probably in a very economical way as well. Yeah.
And then obviously the gateways will convert to your chosen protocol that will then pull into your BMS controller. So, you know, one of the kind of preferred ones we would see or know of is BACnet, and they then would convert them to BACnet objects, which again is a pretty straightforward, unlimited object going into your BMS controller.
It is, and it's done in the gateway. It's done in the gateway, so we don't need to have any other software layer. We don't need to have any other equipment. We don't, apart from maybe a network switch, so we can bring it onto the BMS network. But the gateway is there to convert LoRaWAN into whatever protocol we need. If it's an IoT gateway, then obviously we need to convert it into a protocol so we can take it to the IoT world on the internet, and that's generally using MQTT. If we're going to bring the data points directly into our BMS, virtually all BMSs now are capable of accepting BACnet objects. And in the gateway itself, it is a web-based wizard that you map your LoRaWAN points onto a BACnet object, and then you discover them into your BMS. It really is a couple of steps and you're there.
Yeah, we're also seeing traction in people using kind of just a gateway as a mini BMS. So for instance, if you had a school or a healthcare centre, all of those things that have no BMS controller in them, and you can utilise, you could have your occupancy sensors on the wall, and temperature sensing. You could have your window and door sensors as well, all communicating, and they can then be managing the TRVs that are fitted to the radiators based on occupancy demand. So it's a really simple solution for maybe a school, a healthcare centre, a community centre that I mentioned earlier that don't have a BMS and maybe don't have investment to install a BMS, but then want to meet some of those regulatory conditions that I mentioned earlier. And by doing using a gateway, using those devices, you are creating a kind of mini control system in itself. So it really is endless in the possibilities that you can do with it.
I was just going to say, be careful, Stacey. You're going to do me out of a job if you carry on.
I know. I'm sorry there, Ian. But yeah, it's how you want. And typically in the commercial BMS world, people don't tend to use the cloud. They tend to want their data to go into the BMS controller, which is why you will see a gateway taking that information straight through to BACnet objects and into the BMS controller. So I think we've answered all of the questions, and obviously we are more than welcome for you to get in contact with us, get in touch after. We'll answer any questions that might come up that you might think of when you're kind of digesting this session. All I'd want to say is thank you to Ian and Violeta for supporting and joining us on this. So it's great to have your input and insight, and any further comments that you guys might have on it. And yeah, we'll take it from there.
Thanks, everyone.
Thanks, everyone. So yeah, thank you to the audience. Thank you to everyone that's joined. And yeah, we look forward to getting in contact with you soon and hearing any feedback or questions that you have. So thank you. Thanks. Bye-bye.